Hi everyone, we are excited to share with you more than 20 sample applications that are designed to help you accelerate app development for Qualcomm Linux. These easy to use sample applications are readily available with the Qualcomm Intelligent Multimedia Product SDK, which is a part of Qualcomm Linux distribution. You can also find these sample applications on CodeLinero. Let's learn more about how you can perform object detection on Qualcomm Linux. Developers can use Qualcomm Linux to optimally deploy pre-trained deep learning models on Qualcomm hardware accelerator, such as NPU, GPU, or CPU. There are a few key components that will help you start developing applications for Qualcomm Linux. First, there are the AI sample applications. They help you implement end-to-end use cases and can be customized as needed. Next, there are GStreamer plugins. Qualcomm Linux software offers GStreamer based machine learning plugins for accelerating AI inferencing using TF-Lite and Qualcomm Neural Processing SDK. Additionally, there are GStreamer plugins for pre and post processing. Qualcomm Linux applications of this type utilize specific Qualcomm Intelligent Multimedia SDK plugins, which abstracts the interaction with Qualcomm Neural Processing SDK and runtime. This makes the application development easier because you only need to call these plugins based on the GStreamer. Now let's take a detailed look at the inferencing workflow involved in the object detection on Qualcomm Linux. Livestream from camera is captured using QTI QMMF source plugin, which is a GStreamer plugin. A pre-processing element such as QTI MLV converter takes the camera feed and prepares a tensor to be input to the QTI ML Snappy plugin. The QTI ML Snappy plugin is specifically designed to interact with the Qualcomm Neural Processing SDK. It is a GStreamer plugin and it offers options to delegate the execution to the different hardware runtime such as GPU, DSP or CPU. Qualcomm Neural Processing SDK is responsible for loading and executing neural processing based AI models on the hardware. The QTI ML Snappy plugin produces an output tensor that can be passed by post-processing plugin such as QTI MLV detection. Once you specify the model to be used, it can be loaded and the plugin gains access to the model input and output capabilities. That includes information about the number of tensors, the dimensions, and the data type. Now that we are aware of the high-level inferencing workflow, let's take a look at the key elements of the source code. Creating the GStreamer pipeline involves three main steps. First, create all elements and GStreamer plugins. Set parameters for each plugin and link plugins to create the GStreamer pipeline. You can see how we are creating the GStreamer pipeline, and just by doing some pre-processing using the plugin and specifying the elements to run the model on the DSP. Here's how you can launch the sample app and redirect the output to the file system. We are now ready to see the object detection in action. Here we are running the object detection application. It uses the YOLONAS model and inferencing is done with the Qualcomm Neural Processing SDK. You can see the detection results in the green bounding boxes. Here we see labels for the objects around the house. You can also find more options for different AI models from the help section of the application. Now that you have a good understanding of how object detection works on the Qualcomm Linux, we can't wait to see how you take it further by developing your own exciting apps. Please check our documentation for Qualcomm Linux, the Qualcomm Intelligent Multimedia SDK and the sample apps on our portal. You can also access the source code for our sample applications hosted on CodeLinero. Thank you for watching.